Hello everyone, today is the lab for assignment 1. In assignment 1, you'll need to write and read index as well as calculate some basic features of your generated index. And here I offer you some skeleton code which will be helpful for your assignment 1. And let's go to this web page first. It's some demo code generated before for you guys to use. And as you know, we will use Lucene for our assignment 1, and Lucene has multiple versions. In this demo, we use Lucene 6.2, and you can download it from the related website. And after you go to this web page, you can just click the download button to download all this sample code, and then create a assignment 1 Java project in your Eclipse and copy paste these 4 files here is like that. But after you copy paste this thing, you will find it generates some errors because in Java default library they do not contain any Lucene packages, so you also need to import from outside. And in order to do that, let's go to this Maven repository first. You will need 3 different libraries in Lucene in order to finish your assignment 1, and you can just search it and download it from this Maven repository. I already downloaded from here, and these are the, let's take a look at here. I created a lab folder to hold all these useful library packages, and they are the 3 you need to use in this assignment. It's Lucene core, Lucene queries, and Lucene query parser. You can just download it in this folder and then right-click the Java project, use build path and configure build path, and click the add extra jars, and then select all these 3 jars. Click open, OK. Then you'll find the referred libraries, these 3 are embedded, and then there's no error jumped out from here. After you prepared for all of these things, you go to start to look at the code. The index code is the index files.java is the file to write index given a bunch of documents, and the search files.java is the code for you to read the index, and the states.java is to calculate some basic features in your generated index. Let's read this Java codes one by one. First, let's go to the index files.java. I will briefly introduce this skeleton code first, and then if you guys still have questions, you can post in Piazza. So in the beginning, this is the main function of the Java code. I assume all of you have some programming background, so you know that the main function is the real place that the Java executes. And first one initialize a released array, a released documents to hold all the documents, and then you manually generated 2 documents here. The first one is document 1, the second one is document 2. In the assignment, you are given a bunch of text files as the documents, and you need to write your own functions to load the text files into your memories, and then modify those loaded documents. And here I just manually created 2 small documents here. And after you created these 2 documents, you need to select a path to hold your index. And I just use this folder here. This folder to store all my index. And these 4 lines are the standard for in Lucene to generate index. The first line, you need to initialize the directory, and then you also need to initialize the analyzer. You just initialize. There are multiple analyzers here. You can just choose the simplest one, the standard analyzer, and you need to have an index writer config and give them some settings, and then you initialize the index writer here with two parameters, directory and the index writer configuration. You will use this writer to write and store all your documents into an index. And this is a for loop to iterate all the documents you generated, and this function is the most important. We wrote it here. See that this function is to use the index writer to store all the index. And let's take a look at this function here. So this one is here, and the document, first you need to initialize the document. Then you need to add a string field with the name doc number, and the content is document get dot number. And if you want to store this field, you just use field.store.es. If you do not want to store it, you can just change it to no. If you change it to no, your content will not be able to store it in the index, and you can't retrieve the results from these non-stored fields. And here in this function we have two fields. The number one is doc number, is a string field, and the number two is a text field. The number two is text and is stored as a text field. You need to search what the difference between the string field and the text field. And after you add these two fields, which means your document has two different attributes. The first attribute is document number, and the second attribute is the text. After you construct this document, you just use your writer to add the documents to the index. And then you do it one by one until all the documents are stored in your index. Then you close your writer, and you can just output something to help you to check which step you are in. And that's it for the index files .java. And if you do that and click this run button, you will generate an index here. And see, it's done, which means we already have some index here, and those are the stored index. Lucene uses a very complex way to store the index, so it's not easy for us to know what's really inside. For example, if you click this one of the files, you will find some binary code. Just there's no meaning for that, so we can just ignore. We don't have to truly understand what's inside the index. And if you want to know how your documents are organized, you can just use Lucene embedded functions to write down the Java code and retrieve from this really arbitrary index. And then let's take a look at the search files.java. This Java is the sample code for you guys to read the index. For example, after you get the index, you first locate where it is, and then you initialize the index writer. Remember, in the index files.java, you have an index writer to write index, and here you just use the index reader to read the index. You also need to initialize some settings like index searcher and analyzer, and this set similarity function is the function for you to retrieve the ranking list given a query. And here we use the BM25 model. We will talk about it in our class as well. And after you finish to prepare all these settings, you also need to parse your query. And you need to initialize a query parser first and see that the query parser is for text. And then you need to parse the query string. The query string here is police today. And then after that you will generate a query. object, and you can just see what's inside the query. Then after prepared the index reader and the query, then you can initialize the results, a top docs object to store all your retrieved ranking list. Then use the search function in the searcher to search the query, and it will, if you set up 1000, it will return at most the top 1000 results for you. And this is the number of the returned documents in total, and this one are the detailed content in each document. For example, here the key is the doc is the content in this retrieved documents, and the score is the similarity score. And these are the field, and the text field, and the doc number field. This one will return a doc ID, and then after all, you just close the reader, and let's run this code to test. See, if I search the police today in our generated index, it will only return one matching documents, and the document 0, the returned ID is document 0, and the score is 1.9. The details of the documents are here. Remember, it's exactly match our index here. See, they are exactly the same. And the document 2, as in the documents, there's no police and today in this content, so this one will not be able to return. And after you can write and read the index, you want to know some basic features of your index, such as how many documents in the corpus, and number of documents that have at least one term in this field, something like that. And there are some related functions you can take a look, and these functions also will be used for your assignment 1. You can just simply call these functions like reader max doc and vocabulary dot size, and vocabulary get sum total term frequency, something like that. Let's test what's going on in these files. Let's hit run button here, and see the total number of documents is 2, right? We just manually generated 2 documents, and the number of the vocabularies and the fields, like there are 2 fields, doc number and the text, the number of the tokens, number of postings for this field, and these are all the vocabularies. And I think that's it. If you guys have any questions, feel free to submit to Piazza, or if you think it's very private questions, you can just send me emails. Thank you all, guys. Good luck for your assignment 1.